In the previous section, we avoided race conditions when sharing latest data. By the end of this module, you will be able to transfer buffered data using FPGA FIFOs. Okay, so now we're going to switch gears a little bit. Right before this, we were talking about different methods of sharing latest data. Now let's say you want to transfer buffered data. So in this case, you want to transfer every value from one loop into the next loop, or from one VI to the next VI. So if you want to transfer buffered data, you'd want to use something called FPGA FIFOs. So what is a FIFO? A FIFO stands for first in, first out buffer. The first data item written to the FIFO is the first item that's going to be read and removed from the FIFO. So this is similar to queues in LabVIEW. So with a FPGA FIFO, you can create one that's target scoped, or you can create one that's VI defined. Again, if you're creating a target scoped one, that FIFO is going to be able to be used between loops on multiple VIs running on the same FPGA target. If it's a VI defined FIFO, then that single FIFO will be able to transfer data between multiple loops in the same VI. So first, let's talk about how to create a target scoped FIFO. So the way that you would do that is you would right-click an FPGA target, you would go to New, and then select FIFO. Okay, and that'll launch a configuration window for your FIFO. So if we take a look at this dialog box, we notice that we can give our FIFO a name, and that's the name that'll show up in the project. And also I want to bring your attention to requested number of elements. So this is how many elements that you're going to store inside your FIFO. Okay, and then we'll talk about the implementation as well. So in this case, it's shown as block memory, but there are other ways that you can set that. So you can either use block memory, lookup table, or flip-flops, and we'll talk about that in a later slide as well. So let's talk about that number of elements setting on that previous configuration window we just saw. So the maximum is going to depend on the implementation that has been selected, which we'll talk about in the next slide, and also on the amount of space available on the FPGA for the implementation. So if you specify a value that is too large here, the FPGA will fail to compile. Also, you want to request the number of elements based on the needs of your application. So just try to think of, okay, how much space do I need in that FIFO? LabVIEW is going to specify the actual number of elements in that window, and if the actual number is greater than the requested number, the difference is due to technical constraints on the way that it's implemented on the actual FPGA hardware. So on this slide, we're talking about that implementation setting on the configuration window for the FIFO. So there are three types of implementations that you can choose from. One is flip-flops, one is lookup table, and the last one is block memory. So on this slide, we kind of provide you some best practices of which one you should choose. So let's talk about flip-flops. This implementation will use gates on the FPGA to provide the fastest performance. However, this is only recommended for very small FIFOs. So if your FIFO is less than 100 bytes, then you can use flip-flops. Now, if your FIFO is going to be a little bit bigger, then you might want to use lookup tables instead. So this implementation will store data, the data of your FIFO, in lookup tables available on the FPGA. This is recommended for small FIFOs that are between 100 and 300 bytes. Lastly, there's block memory. So for block memory, this stores your FIFO data in block memory to preserve the FPGA gates and LUTs for your VI. So this is recommended for FIFOs that are going to be greater than 300 bytes. So here we see that you can also create a VI-defined FIFO. So again, a VI-defined FIFO is going to be a FIFO that you can only use between different loops on the same VI. You would go to the data storage and transfer palette, and you would place down a VI-defined FIFO, and then you can double-click it, or you can right-click and select Configure to launch the properties to configure that FIFO. Okay, so now let's talk about how to write and read from your FIFOs on your block diagram. So what you would do is you would place a FIFO method from your functions palette and place it on the block diagram. From there, you could right-click it and then go to Select FIFO, and then select the FIFO that you've defined already, that you want to associate that write and read with. Then you can right-click the object, select Method, and choose Write or Read, depending on whether you want to write or read. Another way you can do it is you can left-click on top of where it says Write on the actual node and change it to Read, or change it from Read to Write. Okay, let's take a look at the FPGA write and read nodes a little bit more closely. So once you have them up, notice that there's going to be a input or output for element. Okay, so this is going to be where you would either write an element or you would read an element from the FIFO. There's also a timeout. So if you take a look at that, Let's look at the one on the left first. So let's look at the FIFO write. So let's say I have an element that I'm trying to write to my FIFO, and then I have a timeout specified there. So if I'm trying to write an element to my FIFO and the FIFO happens to be full already, then it's going to wait for the time that's specified by the timeout. And if there's no space still at the end of the timeout, then the timed out output will be true. Okay, and that would indicate a overflow condition, which we'll talk about more on the next module. Now let's take a look at the FPGA read on the right-hand side. So here we have an element that we're trying to read from the FIFO, and we also have a timeout here. So if we call this read and the FIFO happens to be empty, then this node is going to sit there and wait until there's an element available. Now if the timeout specified times out, then the timed out will output a true. And that would indicate a underflow condition, which is what we'll talk about in the next module as well. Now let's go into LabVIEW and take a look at the FPGA FIFO. So in this demo, what I'm going to do is I'm going to create a target scoped FPGA FIFO item. So here we will go to our FPGA target and right click it, go to new, and then select FIFO. And in this case, I'm just going to call it my FIFO, and that's what the name of it will be in the project. And then here I want it to be target scoped, and here I can define how many elements I want this FIFO to contain. So in this case, I'm just going to leave it at 1023. Here notice that you can select the implementation. So we talked about this in the previous slides of what's going to be the most optimal for you. So here I'm just going to leave it on block memory. Notice that you can also go to data type, and you can also select what kind of data you want your FIFO to contain. So here I'm just going to leave it at I16, but notice you can choose other data types as well. So I'm just going to click OK. And notice that I have my FIFO right here. Now I'm going to right click and create a VI so we can go to the block diagram and write or read to it. So if I right click, I can go to data storage, then I can go to FIFO method. I can place that down, and notice I have to say what FIFO this is associated with. So I can right click this, select FIFO, and select my FIFO. Okay. I can also go over here and drag it from my project into my block diagram. So either way, I can do a write, or I can left click here and change it to read. Okay. So this is how I would write to my FIFO or read from my FIFO. Okay, and notice that here this is the element that I would write, this is the element that I would read, and here we can specify a timeout just in case the FIFO is full when I'm trying to write to it, and here I can specify a timeout in case the FIFO is empty when I try to read from it.